So I'm James Shore. I'm a co-author of The Art of Agile Development. I co-created the Agile Fluency model. And 7 years ago, I launched a Kickstarter called Let's Code Test-Driven JavaScript. It was meant to be a screencast about how to do JavaScript really well using test-driven development. The dirty secret is I didn't know JavaScript all that well. I was familiar with it, but I was by no means an expert. And part of the reason I wanted to do this screencast was to learn more about it, and particularly to learn how to do test-driven development. So to learn, I decided to build the website that was going to host the screencast from scratch using Node.js and build a web server and content management engine. And this is what that looks like today. Now, I was familiar with web technologies, but I had never built a web server before. But, you know, how hard could it be, right? It's got to be pretty easy. I had a limited budget. The Kickstarter had been successful, but if I wanted to keep producing episodes, and I did, I needed to start taking in money in the form of subscriptions. So naturally, I decided to use evolutionary design. And that's what this talk is going to be about, is evolutionary design. So, what is evolutionary design? Well, it's basically this. This illustrates the first 25 hours of development of a simple financial application, a retirement planning tool. Evolutionary design starts with the simplest possible design and then grows it alongside the application's needs. It comes out of extreme programming, which you don't hear about much these days, but that's how I got my start. And in the early 2000s, XP was kind of a big deal. It was really the first popular Agile method, and it set the tone for a lot of what we take for granted in Agile today. It brought us things like test-driven development, user stories, continuous integration. All these ideas came out of extreme programming. Now, extreme programming's motto was embrace change. Ultimately, extreme programming was a risk management engine or process. It was about reducing the risk of software development by shipping early, shipping often, and using that to get feedback about what was needed and changing your plans as you went. Given a fuzzy, unknown future, we would explore the possibilities, try things, do the things that worked best, and thus get close as possible to the maximum value. These are classic Agile ideas, but XP was and still is unique in that it didn't just say, this is what you need to do and here's the process your teams should use. It also said, here are the technical practices to make this possible. And that really is what made XP stand out and still stands out today. And examples of those, of course, were test-driven development and continuous integration. The reason for this is that our typical experience with software development, as Gene mentioned this morning, is that software typically gets more expensive over time. Now, I'm not aware of any good studies about this, but I think we've all experienced it. There are studies, it's just they're not very good. I think we've all experienced this though, right? At the start of the project, things are easy and fast, and you're just cranking stuff out. And then as time goes on, it gets slower and slower, and then everybody leaves, and you come on. And words start being thrown around, like legacy. Anybody experience this? Anybody not experienced this? Yeah, I mean, we've all experienced this. So people call this technical debt. Artie Starr, I believe her session's it hasn't happened yet. She calls this escalating risk, which I think is an even better way of describing it. But if change gets more expensive over time, embrace change doesn't work. If change is more expensive later, it makes sense to fix our requirements in advance and do the most important stuff really early when it's cheapest. This is what the pre-Agile methods were optimizing for, is fixing the requirements in advance so that they could be done when they were cheapest. XP depended on inverting this cost of change. Kent Beck wrote in the first edition of Extreme Programming Explained, this is one of the premises of extreme programming. It is the technical premise of XP. If a flattened change cost curve makes XP possible, a steep change cost curve makes XP impossible. A steep cost change curve makes XP impossible. I think this is not only true for extreme programming, I think this is true for any Agile method. And in fact, since almost all modern software development accepts requirements changes at any point late in the process, I would say this is true for all modern software development. If we're going to accept changes at any point, if we're going to accept changes late, we need to see the blue curve, the bottom curve, not the top curve. So XP was built around making this possible. And collectively, these practices were called evolutionary design. Now the question is, does it actually work? Well, as with the traditional approach, I'm not aware of any good studies, but I have experienced it, and I do have some empirical data. So the main event of my screencast was to build a networked drawing application. It was called WeWikiPaint. And it looked like this. And at the end of the screencast, which ended in 2018, there were 609 15-minute episodes, which is over 150 hours of development. It was all done on camera, and it was all done with evolutionary design. One of the clearest examples of how the cost of changes changed over time was in building the networking code. There was a number of things that I needed to do that were all about the same level of complexity. First, I networked the pointer. So you'll see on the left there's a pointer moving around, and there's a ghost pointer on the browsers to the right. Then I networked the drawing, and then the clear button, and then there were a couple of polish features. I needed the pointer to disappear under certain special circumstances, and I also wanted it to show up if you were using the touch device, which doesn't really have a concept of pointers. Networking the pointer took 12 hours. Drawing the lines took 6.5 hours. The clear button, 2.75. The disappearing pointer, 3/4 of an hour. And the touch pointer, half an hour. And there it is. That reduced change cost curve shows up clear as day. So in short, evolutionary design is a way of achieving the enabling principle of modern software development. If you support changing requirements, you need evolutionary design or something like it. So, what is it? Well, again, this. Kent said in Extreme Programming Explained, first edition, the design strategy in XP is to always have the simplest design that runs the current test suite. I couldn't find an exact quote, but I believe Lord Cunningham said something along the lines of, you want the design of your application to look like it was purpose-built for what it does right now and nothing else. Imagine the best design you could have for the features you have right now, and that's what you want your design to look like. In other words, evolve the design as you go. In practical terms, this involves 3 skills: simple design, continuous design, and reflective design. And these are all enabled and supported by a fast and reliable suite of automated tests. Now, evolutionary design is not appropriate for everything. In particular, it doesn't work when you can't refactor. If you can't refactor, or if it's expensive to refactor, you can't do evolutionary design, because evolutionary design depends on refactoring, which of course is changing the design of your code without changing the design of the code without changing the behavior. In particular, this comes out in reality when you have multiple teams, or when you're publishing software for external third parties to use. So if you're publishing an interface to other teams, don't use evolutionary design on that interface, because if you change it, you're creating a lot of expense for those other teams. Now, Google, I believe, gives their teams the ability to go out and change their consumers, so you can use evolutionary design in that case. But if you don't have the ability to change your consumers, don't use evolutionary design on the interface. You can still implement that interface with evolutionary design, all the internal details, but the interface has to stay fixed. And then also, I've seen people try this, but I've not seen it work well. If you have multiple teams owning the same code base, they don't seem to be able to get the level of coordination required to do evolutionary design and refactoring well. You get a situation where everybody thinks the other team's going to make it better, and they're going to focus on their work, and then things sort of fall apart. So this is a tool for within teams. It's not an architectural technique. There is discussion of evolutionary architecture. There actually was a talk here about that at YOW last year. You can find it in the archives on YouTube. But it's really quite different. It's not the same thing as what we're talking about here. So let's go back to my Kickstarter. I'm going to use this as an example of evolutionary design. Now, this was a project built by one person. So it was much smaller than what you're going to see in typical software projects. But it went on for 7 years, and so it was actually quite substantial by the end. And is not that much smaller than some of the team-level stuff that I've worked on using evolutionary design. More importantly, though, this is small enough that, one, I can share it with you. I have all the data, so I went back and analyzed the Git repository for back 7 years. And I have the permission to share that with you because I did it. And it's small enough for me to show you and for you to be able to understand what's going on. So even though this is smaller than what you're going to see in a real-world team environment, it's still applicable. All the things I'm going to show you really do happen even in larger projects. So it's 2012. I decided to build my own web server. Specifically, I wanted a content management engine where you could drop in files and have them show up as pages or endpoints, just like a static site, only it was dynamic. And this is what it looks like today. I'd also decided to use evolutionary design. I had a lot of experience with it at this point, so I had a lot of trust in it. So the first thing I needed to do was to build a working web server. And so I'm going to show an animation of what that evolution looked like. Don't try to read the details as we go on. It's going to get smaller. You're not going to be able to read it, especially if you're in the back. And the names and so forth aren't really what's important here. What I want you to pay attention to is the motion and how things change over time. So I needed to build a working web server. So there I did. I started, and I stopped. That was the first 3 hours and 20 minutes of development, and then I had a working web server. What you don't see here is that in addition to building out the web server, I also built out my automated build. I built test infrastructure and tests. I built continuous integration, or set up continuous integration and continuous deployment. It was all a production-grade development environment, but very, very, very small. And this illustrates the first pillar of evolutionary design, simple design. We only build what we need for the things that we need right now. In the future, I needed a dynamic content management engine. But right now, I just needed a basic web server. So that's all I built. It's called a walking skeleton. It's bare bones, but it's got everything it needs to go into production. Keeping it simple is probably the hardest thing about evolutionary design. When we build that walking skeleton, and in fact, when we build everything, we do the simplest thing that could possibly work. This is Ron Jeffries' phrase. So I had a build script, but it was only 65 lines long. It only did linting and testing. I had continuous integration and continuous deployment, but they were just another script. There was no special tools, and when I wanted it to run, I went to my command line and I typed the name of the script and I pressed enter. It's really tempting to put in all the latest and greatest. Kubernetes, microservices, Bazel, Jenkins. And some of it you might need. But a lot of it you aren't going to need. Everything you add is something that takes time to build or configure. It takes effort to maintain, And it increases your mental burden and the cost of change. Because now, when you're looking at that part of the system, you have to understand more things. I worked with one team that had so many frameworks that the friction on that team was the biggest I've ever seen. Nobody could get anything done because every time they wanted to do something, they had to go do research on 5 or 6 very complex different frameworks and understand them. And they couldn't keep it all in their heads. So even if you think you're going to need it, don't add it until you actually have a proven need. Understand what the tools get you, and don't put them in until you need the actual thing it gets you. And this is true for software design too. Who's had experience of working with code where there was a feature needed and somebody knew this feature was coming up, and so they put in design around that feature, and then they got it wrong? What was that like? That kind of sucks, doesn't it? Would you rather that they just had not put in any design at all? When somebody puts in design and they get it wrong, it ends up hooked into all these different parts of your application, and it's really hard to take out. It's harder to rip out design that's wrong and put it and correct it than it is to add design that doesn't exist. So do the simplest thing that could possibly work. When you think, but I'm really going to need this, well, wait until you actually do need it. Your future self will thank you. So that's how I built a working web server from scratch with tests, continuous integration, continuous deployment, automated build in 3 hours and 20 minutes. I cheated. I did very, very little. And that's the secret. Of course, some of it I was going to need eventually. I wasn't done. But what I was going to do was I was going to add it incrementally. So what I had to do next was add support for dynamic pages using Jade. And what you're going to see here is that the design is expanding, but it's only expanding enough to support the new feature I'm adding, which is dynamic pages. And then I needed to support headless endpoints and authentication. And again, note how each design change is driven by an actual need. And then finally, I needed to harden the server, make sure it supported the RFC 2616, which is now 72 something, and fully comply with the HTTP spec. And then I had a fully complete production-ready content management engine and web server. It took 7 weeks and 2 days. I was working slightly less than half time, 15 hours a week on average. The rest of the time was spent working on fulfilling Kickstarter promises. The total time was 109 and 3/4 hours. I tracked these things. This is what the whole process looked like. So that's simple design. Start with a walking skeleton, do the simplest thing that could possibly work, remind yourself you aren't going to need it, and incrementally add one feature at a time, only adding the things that you think you need when there's a proven need. And as you go, improve the design. Part of what makes evolutionary design work is test-driven development. I hear a lot of misconceptions about test-driven development, so I'm going to very, very briefly review it. The key feature of test-driven development is that it's a continuous series of validated hypotheses. You're taking really small steps and checking your understanding of the system at every step. Each pass through this loop is a very small amount of code, about 5 lines, and each loop includes an explicit prompt to stop and think about design. So I'm going to show you a video. This is a simple algorithm developed with test-driven development. It is sped up 20 times, so what you're going to see is flashes when the tests are run. It'll flash green when the test passes, flash red when the test fails. And the longest time between each of these steps is going to be 56 seconds. But it'll be 3 seconds here because it's sped up 20 times. Notice that there's just a few lines of code added during each step. And notice how the production design, which is on the right, is constantly being tweaked. If you're photosensitive, you might want to look away or shut your eyes because there's going to be some flashing lights here. The video's done. You see this constant attention to design in the development of my content management engine. This is the first 2 days, and I'm constantly adding and removing and renaming methods. This is continuous design. It's essential to making evolutionary design work. Not only do we make the design as simple as we can for just the features that we need right now, we also constantly review and improve the design as we go. Several practices from extreme programming help make this work. Now, they're not required. You can do continuous design without using these practices, but they are helpful. And the most important of them was called merciless refactoring. Before adding any code to the system, we look at the design and say, how can we change the design of the code? How can we refactor to make this code easier to add? And then after adding some code, we look at the design and say, how can we refactor this code to make it easier to understand and maintain? And we're always looking at this, merciless refactoring, not just refactoring, but merciless refactoring. Extreme programming also expected that programmers would change each other's code. This was called collective ownership. And the statement that Kent wrote in the first edition of XP Explained was, whenever you see opportunity to add value, you must do so. You must do so. Regardless of who originally wrote the code, you must add value when you see the opportunity. And sometimes this is adding features, but more often, this is decreasing the cost of ownership. In other words, if you see an opportunity to make the design easier to understand, you take it. If you see an opportunity to make the design better, you take it. With a caveat that you only do that in the parts of the system that you're working on. You don't go off and gild the lily. Now, maintaining awareness of what everybody's working on and how the design all fits together in a large system, that takes a lot of work. That's hard. And merciless refactoring and collective ownership require that you have that kind of situational awareness. So Extreme Program dedicated half of the team at all times, half the team was dedicated to thinking about design. You've heard of this, but you probably didn't realize that's what was happening. It's called pair programming. When you're pairing, one person is typing and the other person is supposed to be thinking about design. They're thinking ahead, thinking about how things fit in, and looking at how what you're doing now fits into the big picture. You've probably heard of pair programming as continuous code review, and it is that because XP's practices tend to perform double duty. But more valuable than the checking, because you don't really need somebody sitting and watching over your shoulder and saying you missed a semicolon. People do that. It's really annoying. You don't need that. What you need is, how does this fit in, and what should I do next, so that you're always just making progress and creating better code that fits in well. Nowadays, people also use mob programming, which is even more people thinking about design. And then finally, because the design is constantly changing, because people are constantly refactoring, we're always bringing the code back together. We're integrating it into a common branch so that it doesn't diverge. And this was called continuous integration. Very early on, the tool vendors co-opted the term and started calling continuous integration a tool. But continuous integration is not the tools that the vendors provide. Continuous integration is nothing more and nothing less than bringing your code back into a common branch at least every few hours.